I've only missed one so far. And then for the second column, it would be -2. So as long as you study, I take care of the signs for you. You take care of the multiplying. Give me all the numbers you can think of that multiply to give you 24. It's 1 and 24, 2 and 12, 3 and 8, 4 and 6. I had 2 students that came to me yesterday and said, "Oh, look, but I've learned to do it a different way. They do it with an X. I know that's the way other teachers teach it." I don't fully understand the X, but from what I gathered from it, it's the exact same thing. The only difference is that the way I do it forces you to write down all the pairs, meaning it's more written and you see it, versus where the X thing, you're forced to come up with the pairs in your head. I would think writing it down is better, but hey, you know what? I've gotten to the point I'm not gonna fight you on it. If you somehow feel that this is better, then you go do it. I can tell you that one of the people that told me that that's the way they learned it is better and blah 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 got a 0 yesterday. So maybe they didn't learn it as well as they thought. Okay, so now with the arrangement of signs, when both columns have a negative on top, what are we gonna do with the signs? Good, small positive. This is helping you so that you don't have to do it all in your head. Big negative. Do any of these add up to -2? Which ones? 4 and -6. Good. So this is what I want. Now here comes the hard part. Because so far you're like, well, Mr. Romero, this is what we've been doing every single time. How could you say that this is hard? Well, no, because you just have to remember the extra steps. Because A was not 1, look, I'm still going to write that, what was it, a 4 that we took out? Yeah, I'm still going to write the 4 first. But now I'm going to write 2 parentheses. At the end of the 2 parentheses, I'm going to write the +4 and the -6 that I got from the chart. But now instead of just writing the variable, which was x, I have to also write a in front. So it would be 3x and 3x. And what I have to decide is if any of those parentheses have a common factor, just like the 4. I need to divide it out. But unlike the 4, I'm not going to keep it. I'm just going to throw it away once I divide it. I know I'm going to keep the 4. Do 3x and 4 have a common factor? No, so I'm going to keep that too. You don't have to draw arrows. I'm just trying, it's just for visual purposes. How about 3x and 6? Yes, what can those be divided by? By 3. They can both be divided by 3, so you're expected to do so, but you're not going to do anything with that 3. Once you divide it out, you just throw it away. Caca. Keep the 4, keep the 3x plus 4. 3x divided by 3 is x, -6 divided by 3 is 2, and now we're done. If this were like yesterday, I get it. I get it. I know that the format wasn't ideal, but it also shouldn't have been overly complicated. As long as you know how to factor and you know what your factors are, then you go after the fact and you look for the 4, you look for the 3x plus 4, and you look for the x minus 2. I don't know what order they're in. Just make sure that those are the only boxes that are checked. Any questions there? David, no? Hey, will you look at that? It's a quadratic trinomial, and what's the lead? 3. Just like the last one, do we have a common factor? Yeah, unlike the we don't have a common factor here. Why can this not be a perfect square trinomial? The 8 is negative, the 8 is not perfect, the 3 is not perfect, so let's do a chart. Are these almost like the same numbers as the last one? Oh, we got the 3 and the 8, but now it's -2. So A is 3, B is 10, and C is -8. So when AC, A times C is going to be -24. B is 10. Think of all the numbers you can multiply to get 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Under this scenario, when you have a negative on the left and a positive on the right, what do you do with your signs? Small negative, big positive. Which one gives you +10? negative 2 and positive 12. So the only difference between this one and the last one is that we have no greatest common factor, so it's just the two parentheses. At the end of the parentheses, I'm going to put these numbers here that I just got, negative 2 and positive 12. Those are the second in each one of those. But in the first term, I have to put the variable, which was a. Don't just get used to always putting x. But also the number that was in front, which was 3. Do 3a and negative 2 have a common factor? No, so I drop it as if it was high. Do 3a and 12 have a common factor? What? 3. They can both be divided by 3. So you get 8 plus 4. So when you're done, those are the two that you check. Those are the factors. There are no other factors. Those are the only factors. Hey, so another indicator that showed that just it wasn't just time that was an issue. You guys didn't know. You want to know what answer that's all about? Over and over and over and over again. No solutions, which I don't believe there was one that had no solution. From my number 17 and prime, which I don't think there was one that was prime. But so it's just prime. If thou dost not know what you're doing, it must be prime. For the third time in a row. What type of problem is this? A trinomial where the lead is not 1. That's what causes us to do these extra steps at the end. And now we'd be done right here if the lead is 1. Is there a greatest common factor? No. Could this possibly be a perfect square trinomial? No. So 2 times negative 15 is negative 30. B is 1. Let's think of all the numbers that we can think of that multiply to give you 30. 1 and 30, 2 and 15, 3 and 10. I literally started off the unit telling you what is the biggest problem what kids struggle with. It's not just you guys. It's everywhere across the board. It might even be the biggest reason why Algebra 1 is the most failed class across the board in the United States, regardless of subject. Algebra 1 has the highest failure rate of any class in all of high schools. And this factoring is probably the most difficult one. And why do people struggle with factoring? Because they know the times tables. So yeah, what would be the other option if you're not good with your times tables? Yeah, you can do this with a calculator. 30 divided by 1, 30 divided by 2, 30 divided by 3, 30 divided by 4, 30 divided by 5. But then what are you sacrificing if you have to use the calculator every single time? Under this scenario where the first column is negative and the second column is positive, what do you do with your signs? Small negative, big positive. And look, just to be clear, if you are able to do this stuff in your head, instead of doing this X thing, like you don't have to list all the factors. There used to be a time, long time ago, where to force kids to learn their times tables. Like I made them do everything, but if you know that it's going to be negative 5 and 6, and you only want to write negative 5 and 6 to save time, that's fine. I can live with that. Because there's no GCF, and I'm going to write the negative 5, and I'm going to write the positive 6. But because A was not 1, like all the way in front was a 2, so I'm going to write the 2 along with the x. The 2x and negative 5 have a common factor. No, so I just rewrite it. Can 2x and 6 be divided by a common number? 1, 2. What did you? Oh, was that you? Who said 3? That was it. Questions there? For the 4th time in a row, what do we have? A quadratic trinomial with a lead term that is not 1. But wait, there's more. The good news here is that not only do we have a GCF, but the GCF happens to be the same as the lead. So when I correctly factor out that GCF, Viola, what has my lead term now become? A 1. I'm going to keep the 5 on the outside. That's the greatest common factor. It is a factor. If I had the test in front of me, I could go ahead and click 5 already because I know 5 is going to be a factor. I know that the rest of it cannot be a perfect square trinomial because 6 is not perfect, so I don't even need to waste my time testing it. A would be 1, -7, and 6. This would be an easy chart because A times C is 6, -7. The only numbers that multiply to give you 6 are 1 and 6 and 2 and 3. Under this combination, what do we know about our signs? Both negative. Study, study, study. Study, study, study. What? There's a multiplication column. The only way to multiply and get a positive is either both positive or both negative. But if I needed to add up and get a negative, I can't add 2 positives and get a negative, so it has to be 2 negatives. And when you look at that, it worked. And there's even better news. That's that because A was 1, yeah, I'm going to leave my GCF in front, but because A is 1, all I have to do is write my variable -1, my variable -6, and all the children rejoice because we're done. No extra steps required. You look worried, Cassandra. No? If you have questions, ask. You got a real test tomorrow. For the 5th time in a row. Geez, I wonder why these were missed so much. If only somebody would have warned me and I would have paid extra attention to these. Quadratic trinomial, lead is not 1. Do we have a greatest common factor? No. Could it possibly be a perfect square trinomial? No. There's 2 is not perfect and then there's 6. Now the good news here, at least, if there is any good news, is that every term is positive. So you're less likely to make a mistake with signs, at least. You know that everything's going to be positive. So we got a 12 and we got a 7. You might be reducing your head because of the fact we're not dealing with negatives, but just for fun, I like to show off. Write every combination that multiplies to give you 12, which one adds up to 7. 3 and 4. Now I will bring out my parentheses, but I have to remember that A was not 1. So instead of just writing x, I have to write 6x and 6x, and then I write plus 3 and plus 4. If I have any common, this is a shortcut. This is really like, I almost have an ethical dilemma of teaching it this way, because that's really not the way it's supposed to be taught. There's a much more formal way of doing this, where you split the middle term and you do a process called grouping. But I taught that for over a decade, and it's just, yeah, like the high achieving kids would be able to understand it, and nobody else would. So this is kind of a shortcut. You just got to keep that in mind. So like now, if I have a common factor, I'm going to divide it, but I'm going to just throw it away. What does the first parentheses have in common? 3. What does the second parentheses have in common? 2. So this becomes then 2x plus 1, and this becomes 3x plus 2. Do you know the main reason why I give all these practice tests? Other than to make your life miserable? No. How many of you were blessed with the ability to just learn things the first time that you see them? When you're exposed to a stimulus, you just look at it and bam, it makes sense and you understand it right away. Anybody? So more than likely, when you learn something new, what tends to happen when you try to do them on your own? When you're learning a new skill, and then you try to do it for the first time on your own, what tends to happen? It could be anything. It doesn't have to be math. It's just anything. Teaching you how to I don't know, rebuild an engine. I don't know, whatever it is. When you're learning for the first time, what tends to happen? You make mistakes. And then how do you learn? How do human beings learn? Once they make mistakes, then they correct their mistakes, sure. So how can you apply that to what we're doing? Well, I expect every single one of you to make mistakes. Nothing wrong with making mistakes. But when and where should those mistakes be being made? When do we practice? At our homework. Yeah, I know every day. I mean, I got 50 minutes or so, and I can do a few on the board. But the mistakes should be occurring at home. I have a place on the e-class where you post them. We go over them, and then hopefully you can learn from the mistakes there, so that the mistakes don't happen on the real test. But I've done this long enough to know that a lot of you guys don't. So why do I give practice tests? Because it forces you to at least try. Because now the hope is that even if you're no pun intended, but even if you have no clue what you're doing, just the fact that I made you sit somewhere and try something on your own. Now, when we're going over this, you're seeing it for the second time. Hopefully, we can correct the mistakes now and not when it really counts, which will be tomorrow. Why we make it with the classwork grade? It's classwork. It's just work that I'm forcing you to do as opposed to giving you homework and then you guys just not doing it. Okay, bad news is like what, the sixth or seventh one we've had in a row that has a trinomial with a lead that's not 1. But what's the good news? If you have a GCF, and what's that GCF? 2. So when I bring out the 2 and divide everything by 2, what does that make my lead term? 1. This is not going to be a perfect square trinomial because the 10 is not perfect. It's also negative. But my A is going to be 1, my B is going to be 3, my C is going to be negative 10. Makes my number smaller. So we have a negative 10. We have a 3, 1 and 10, 2 and 5. Under this combination, how do I adjust my factors? Hmm? Small negative, yeah, big positive. And be so happy. And because we factored out the GCF, I even looked at tomorrow's test, and it even reminds you at the beginning, factor out a GCF first. If you have one, you won't always have one, but if you have a GCF, take it out first. It is actually possible if you have a GCF to take it out at the end, if like you forget it, but there's a good chance if you forget it at the beginning, you're going to forget it at the end. So take it out first, and then you just did yourself a favor, because now I have that 2 from the beginning that I brought out, but it's just going to be x minus 2 and then plus 5. There's no need to do any other steps. Yes. There are, from what I remember, 2, but one of them counts as a bonus, meaning if you get it wrong, it doesn't count against you. That's off the top of my head. You want to do that one next? All right, just for you. The dimensions of an old stage, it's very hard to plan for word problems because, yeah, I could go over this stuff here that we're talking about a concert hall, but then now on the test, there's a word problem about throwing a football across a football field, and how far does the football fly or something along those lines, where the math would be identical, but you have no clue because the words change. It's very hard to prepare for word problems. But, okay, let's see. The dimensions of an old stage at a concert hall were 30 foot by 15 feet. One of the best strategies for word problems is draw a picture. So if they're giving me dimensions that are long and wide, I'm guessing they're talking about a rectangle. So 30. Speaking of which, on the last lecture I did on the equations, I was able to actually do a word problem in my other classes that I couldn't. That day you guys wasted more time than normal. So it is on the video. If you go back and watch the video from Monday, you should see a word problem there too. If that helps. So this is 13 feet. This is 15 feet. So the new stage will have a total area. So this is an area problem. On the inside, there's going to be 1,000 square feet. The dimensions of a new stage were created by adding the same distance, which is x, to the width and the depth. So on this new stage, Okay, this new space that's going to be 1,000 square feet, they are going to add x to both of the dimensions. So what will be the new width? If currently the width is 15, and I'm going to add x to it, what would the new width be? If I'm going to add x to it, what would the new width be? 15, not 15x, 15 plus x. If the original length was 30, what would the new length be? Thank you. It would be 30 plus x because I'm just adding the same x to each one. Okay. So now they want to know what is x. How is the area of a rectangle calculated? Even though I know it's not just, it is length times width. So now it's just substitution. The 1,000 is going to go where the area goes. What's going to go where the length goes? 30 plus x. What's going to go where the width goes? But wait, Mr. Romero, how about if I put the 15 plus x first and then the 30 plus x? That's fine. Wait, but Mr. Romero, how about if I put x plus 30 and then x plus 15, like where I put the x first? That's fine too. Addition and multiplication are both commutative. The order does not matter. Well, see, the good news is, yes, this side is in factored form. How do you know it's in factored form? What do you see? What symbol? Parentheses. But the bad news is it's not equal to 0. So even though I have those parentheses there, I'm going to have to just waste them. I'm going to have to get rid of them because I have to get rid of that 1,000. How do I get rid of those parentheses? Just take. I'll give you a clue. It starts with fo and ends with ill. 30 times 15 is going to be, is it fo 50? Plus 30x plus 15x plus x squared. We went over this. We talked about the box method also when you FOIL. So 1,000 equals, I'm going to do myself a favor and I'm going to write this in standard form. I'm going to write the x squared first. 30 and 15 is plus 45x, and then I'll write the plus 450. Have I confused anybody with that? In order to make this equal to 0, I'll do minus 1,000 and minus 1,000. So I get 0 equals x squared plus 45x minus 550. And then now I have to go back and factor. Did I have it wrong in my head? I got 450 minus 1,000. Negative 550. So my A is 1, my B is 45, and my C is 550. But yeah, I'm going to have to think of now all the numbers that I can think of. Sorry, negative 550. What are all the numbers I can think of to multiply to give me negative 550? Practice makes perfect. So 1, 550. 2, it has to go into an even number. That should be 275. 3, I'm not sure about 3. So just do it on the calculator. 550 divided by 3. Does that work? It actually shouldn't work. No, it shouldn't work. 5 obviously will. That one should be 110. 5 and 110. 6 won't work because 3 didn't work. 7, check 7. I don't think it will, but just to be clear. 550 divided by 7. No, 7 doesn't work. 8 doesn't work. 9 won't work because 10 didn't work. 10 will work. 10 and 55. And actually, I'm going to cut it off right there because I already know that's going to work. Under this scenario, small negative, big positive, which is the one, yeah, this one gives me 45. And because A is 1, even though this is a lot of work, at least because A is 1, I could just say that x minus 10 and x plus 55 equals 0. Once I've factored, what are you supposed to do next? Make each factor equal to 0. Say x minus 10 equals 0, x plus 55 equals 0. Plus 10 and plus 10, x can be 10, or minus 55 minus 55, x equals negative 55. Now let's go back to when you say, and you go look, I don't remember what I put as answers here, but let's say that both of those answers are there. This is a word problem. There's context. The words, like the actual numbers mean something. This is what you're adding to a floor. Where number one, adding a negative 55 would not be making a floor bigger. But number two, if I were to get negative 55 and add it to these, it would make them negative. It's too big. Like 55 would make them negative. You can't have negative dimensions. So in reality, in the real world, there's only one answer that works, and that's 10. The only answer there should have been 10. Let's see if I can get these last three done before we leave. Okay, here, equations. What should I do first? Make it equal to 0, plus 13x plus 13x. If it's not done already for you, you have to do it. Write it in standard form. 5x squared plus 13x plus 8 is equal to 0. There is no GCF. There is no perfect square trinomial, so I got to do a chart like I've been doing all day. At least everything's positive. 5 times 8 is 40. Just to save time, what two numbers multiply? This is going to be positive 5 and positive 8. But because A was not 1, when I write this plus 5 and plus 8, also don't forget it was equal to 0 with the equation, I have to write the A in front, so it will be 5x and 5x. Do any of these have a common factor? The first one, divided by 5. And x plus 1 and 5x plus 8. So x plus 1 equals 0, 5x plus 8 equals 0. Minus 1 minus 1, x is negative 1. This one you solve just to save time, you end up getting negative 8 over 5. Now, if memory serves me, this was the one that when you look this up, the negative 1 was there, but the negative 8 over 5 wasn't. But if you look at the directions, it says list any solutions. So of all the solutions that were listed, can you say that there's no solution? No, because I got solutions. Now, if these are my two solutions, but this is the only one that's listed, okay, then just pick that one. You pick the ones that match, the ones that are there that you got. First step, doing free ones for you. These are first step is not GCF. First step on an equation is to make it equal to 0. I want to write this in standard form. 2x squared plus 7x plus 6 is equal to 0. There is no GCF. It's not a perfect square trinomial, so A is 2, B is 7, C is 6. So we got a 12 and a 7. Just to save time, we've done enough factoring. Yes, did I do something wrong? Well, because if I move the 2 to the other side, it makes it 2 negative. And that factoring does not work well with a negative lead. If you go back and look at the videos when I taught this to you first time, you want them to end up on the side where the lead is positive. If you're getting an A that's negative, that's going to make factoring basically impossible. Can you think off the top of your head of two numbers that multiply and give you 12 and add up to 7? 3 and 4. So if you know how to do it in your head, I don't have a problem with you doing it that way. So we got 2x, because A was 2 plus 3, and 2x plus 4. Do any of these have a common factor? Yeah, divide by 2, so you get 2x plus 3 and x plus 2. If I had more time, I would work these out, but I would hope you know how to solve a linear equation. Once I make each one equal to 0, 2x plus 3 equals 0, x plus 2 equals 0. This should give you negative 3 over 2. This should give you negative 2. What time is the bell ring? Okay, 15. Okay, so I can finish the last one. Any questions here? Okay, the good news is that this one's already equal to 0. But the bad news is, again, the lead is not 1, and there's no greatest common factor, or this is not a PSD either. A is 3, B is negative 10, C is 3. At least the numbers are not too big. Can you think of two numbers that multiply to give you 9 add up to negative 10? Negative 1 and negative 10. Remember, in this scenario, both numbers have to be negative. So now I go straight to factored form. I would put 3x minus 1, 3x minus 9. Don't forget this is an equation, so I put it equal to 0. I can already tell you what's going to happen tomorrow, especially if you're not paying attention, you're joking around with your friends, and I'm warning you that you guys see kind of how this looks. So then tomorrow they're going to give you expressions which don't have an equal sign, and once you finish, you're going to write equal 0. Even though you're not solving anything, it's just because that's the way it looks on the notes. But that's what my teacher taught me to do. They taught me to always put equal 0. No, just on equations when it's already equal to 0. Do any of these have a common factor? This can be divided by 3, so I get 3x minus 1, x minus 3 equals 0. Make each one equal to 0, 3x minus 1 equals 0, x minus 3 equals 0, x can be 1/3, x can be 3. I realize that I'm skipping steps there, but I would assume that if I would have started you with just this and just this, that you would know how to solve it. Any other questions for me?